Okay. Welcome to energy, which, according to Alan, was one that you guys were having trouble with, I guess. I didn't know that,
I
but
think
no
I
idea.
remember that.
Okay, so first of all, um, does anyone have any way that they think they can explain what energy is? Wild guesses are appreciated. Anything that you think energy is.
It's like the
Ball.
thing that makes things happen.
Okay,
Okay, I got
valid.
this. So, uh, uh, the ball, it go, it go roll, okay, and it go fast, and then it slow down, but it go up high. Yeah. Energy cannot be created or destroyed, and mitochondria is the powerhouse of the cell.
I
All
don't know
right,
what
you
that
know what?
last one has to do with energy, but
I mean, technically, like all of Thehan's answer, and the middle to last part of Ellie's answer is pretty much correct. Like it's not something that actually exists. It's just a construct that we define as being conserved, and just something essentially you use in physics to figure out problems. It's not like something that you can actually have or exists. It's sort of just a construct we've made to make things work.
Is energy a force?
no.
Energy is not a force. No, forces
Okay,
can
thank you.
cause a change in energy, but it's not a force. Um, So onto that, whenever we have a system that's energy changes, so if something changes temperature or it starts moving or rotating, anything like that, where we would say its energy changes, we would say that work is done on the system. And the key thing to remember is that the change in energy, or we would say delta energy, is the same as work. They are just two different terms for the same thing. So if someone says what is the change in energy in a system, or if someone says what is the work done on the system, they mean the exact same thing. Obviously, it's more common to talk about work, but that's all that work is just a change in energy. So can anyone tell me what energy is measured in?
Joules.
Joules, that is correct. So if we know that energy is measured in joules, does anyone know what work is measured in?
No.
All right, so think about if we had displacement, for example, what is displacement measured in?
Meters.
Okay, yeah, most commonly meters. So what is change in displacement measured in? It's not a trick
Wait, can
question.
you repeat that?
So I'm relating it to displacement. So if we said that displacement is measured in meters, what is change in displacement measured in? It's not
Also
a trick
meters?
question. What was that? I couldn't hear you.
Is it also meters?
Alan, I can't hear what they're saying.
It's also meters.
Yes, also meters. Okay, good. Yes. So if displacement is measured in meters, then change in displacement is also measured in meters. So if energy is measured in joules, what would we say work, which is the same as change in energy, is measured in?
It's just not a
Still
trick
not,
question.
still not a trick question
Wait.
here.
Oh,
Go.
I got this. In meters, guys.
I
Is it a jewel?
yeah.
Joules.
I
It's
don't
also
know.
joules.
I don't
They're
know.
both
I'm
It's
joules.
like
listen.
force
Yo,
times
I'm getting
distance,
ready
right?
for tennis
Something
right
like
now, and
that.
I'm just listening in. So I just threw an answer that I.
Wait, I got it. It's meters. Okay.
Wait,
Yeah,
if it's
joule.
force times distance, wouldn't it be like newtons times meters or something?
Ah, Nathan, do you want to write out what the base units of joules are?
Okay,
Dan, what
sure.
have you done?
So, well, first of all, before you get to that, so technically you're right as well. It's also that, and I'll explain in a second. But as far as the question was concerned, it's joules. Energy is measured in joules. Change in energy is measured in joules. Work is measured in joules. But to get to more specifics, joules, and this is not. Well, actually, you kind of need to know this, so this is important. So joules is kilogram meters squared per seconds squared, right? Alan, I'm correct in that, right? Yes, I'm not
Uh,
stupid.
e
Why is it not all showing up? I wrote more, and it's not showing up on the projector.
it'd be
Oh, there it is.
kilogram meters here. Yeah.
All right. So kilogram meter squared per second squared. And we also said that joules is also the same as force times distance, which is going to be Newton meters, or newtons times meters. And does anyone know what newtons are?
Kilograms over like second squared or something like that.
So if you think about it, right, in order to get force, you normally do mass times acceleration, right? So mass is in kilograms, and acceleration is meters per second squared. So that means joules, or sorry,
What's newtons?
newtons.
Yeah.
Let me erase J and write N. Newtons is kilogram meters per second squared. And so if we then bring this meters from joules down here, we end up with exactly what we had at the beginning, kilogram meters squared per second squared. Because kilogram meters, we have the second meter, so it's meters squared over second squared. So any of these answers are technically correct for what energy is measured in. It's measured in joules, it's measured in kilogram meters squared per second squared, it's measured in Newton meters. You could say it's measured in kilogram meters per second squared meters. Any combination of these is correct, to answer your question. But obviously, if they ever ask you, to what is energy measured in, it's joules. Don't write kilogram meters squared per second squared. All right, we lost Sarah. Oh, Sarah's back. Okay. Are there any questions so far? And by the way, while they may not explicitly test you on what is the breakdown of energy, for example, it is very helpful to use if you're ever doing dimensional analysis, which will probably come up a lot. But anyway, are there any questions about this and the breakdown of units and just energy and work in general so far? Okay. So, as Thehan sort of said earlier, when we're talking about moving a system, about applying a force to a system to move it, we can say that the work done on that system is the force, we write it like this, force parallel to distance times the distance. Or you would say it's the product of the component of the force in the direction of motion times the distance through which the force acts. So essentially, if I were to have a box and we push it this way and it moves in that same direction, then the force parallel to distance is just the force we applied, because the force we applied is already parallel to the distance it goes. Whereas if I had a box on a surface, and let's say I push it downward like this, but it moves this way, then the force parallel to distance is going to be the x component of this force. Is anyone confused by this so far? Anyone have any questions? Okay.
I get to find out what the questions are when we start going over the sample questions.
So actually, going from this drawing I just drew right here, okay, if I said that the angle of the force was 30 degrees below the horizontal, how could we, and this just comes back to forces and vectors and that sort of thing. I'm just going to draw it over here. We have a vector that is 30 degrees below the horizontal. How can I get the x component of that vector? Or the horizontal component of that vector? Of that force?
Could you repeat the question?
Yep. So if we have a force, here, I'll redraw it. So it's coming from this image up top, but I'm just going to redraw it down here. If we have a horizontal line here, and I have a force that's pointing downward like this, and it is 30 degrees below the horizontal line, how can I get the x component of that force?
Trig?
Yes, with trigonometry. Specifically, what would you do?
You would have to do the x component would have to be, depends on what you know. If you know the force, then it would be sine of 30, right?
So let's draw it out as a triangle, right? If we know this is the force we're trying to get, and we have this and this, and we have the angle, 30 degrees. Actually, I'm going to draw it out this way. Yeah, because it's going to make more sense if I draw it out this way. This way here. And we have 30 degrees. So if we know this angle here, okay, never mind. I'm scratching that. We're going to draw it the original way because it's just confusing me. I apologize. So this here is 30 degrees. If we did sine, right? Sine is opposite over hypotenuse, right? And then cosine is adjacent over hypotenuse. Or yeah, cosine is. So this over here is the component in the x direction. So what trigonometry function would you have to use to get the x component of the vector?
The x component. Wait, so
Yeah, I'm not saying you were wrong earlier. I'm just drawing it out, by the way.
yeah, it's still sine though, right?
Yeah. I was just making sure that everyone else understood it. But yes, it's still sine. So in this, the way that I've drawn it here, we would say that the f times the sine of 30 is equal to the force in the x direction, right? And so this is one way to get it. Now, here's something that is sort of confusing. 9 times out of 10, you will see the equation for work done on a system written as f cosine theta. That's not a theta. Theta d, right? Have you guys seen this written out before? I'm assuming he's shown you this. No. Okay. Well, this is the most common way to write it out, and I would actually avoid using this because the problem with this is that you can very often get the angle wrong. Like for example, in this case, because I drew the vector below the horizontal, it's sine, right? So the best way to figure out your components is pretty much always to use your use trigonometry. So just remember, if you have a vector like this and you know this angle, right, then sine will get you the x direction here and cosine will get you the y direction. However, if we had it like this, where we instead knew this angle, right, whereas in the original situation we knew the angle over here. If we know this angle, then in this case, cosine is going to be the y direction, sine is going to be the y direction, and cosine will be the x direction. So biggest takeaway here is just whenever you're dealing with vectors and angles, make sure you think about it in terms of a triangle and use trigonometry. SOHCAHTOA. I'm assuming everyone here knows that. Does anyone here not know that? All right, cool. Sorry I went on a bit of a tangent there, but that's the important in this unit particularly. You deal with a lot of angles and vectors, but the biggest piece is that whenever we want to deal with the work done on a system by a force to move it, it's always the first force parallel to the direction of movement times the distance it moved. Is there anyone who has any questions about that? And Alan, if you have anything to say, go ahead.
Nothing from me.
Okay. So let's say that we have a lawnmower that I'm going to draw as a very high quality box with a line. And we have a person. Okay. And this person pushes the lawnmower with a force like this. And here's the ground, right? And so that force makes an angle of 40 degrees with the horizontal. So if this is the horizontal here, it is 40 degrees below the horizontal. So that's this angle here, not this angle. So this angle over here. And let's say that it moves, with this force, he moves it 4 meters in this direction. And the force he applies is 50 newtons. How would you figure out what the work he did on the lawnmower is?
Did you ask what the work was on the lawnmower?
Mm-hmm. Yep.
So it's force over distance, right? Force times distance. So it would be 200. Sorry.
So 50.
Yeah, 200.
So 50 newtons, remember, is the force that he directly applies, right? But he applies like a sort of downward force like this.
Oh,
if you
it's
look.
at an angle. Oh.
Yes.
Oh, okay. My bad. Hold up.
Well, you don't even have to calculate it. Just tell me what would you have to do.
Well, if it's 40 degrees is from horizontal, right?
40 degrees is from the horizontal, yes.
So it would have to be, and then the hypotenuse is the one that's 50, right?
Correct.
All right. So then it would just have to be, cosine of 40 equals x over 50, and then you just do that whole thing times 4. Sorry, not cosine of 50, cosine of 40.
Yeah.
Cosine of 40.
Yep.
And then it's x.
And so the easiest way, and that is correct, I'm just going to draw it up for everyone here. The easiest way, again, like we said, is sort of draw your triangle. So we said that that's the vector there. 40 degrees is here. And that's from this horizontal line here. We connect it up here. Sorry, that is over there, right? So that's 40 degrees. So if that's where we know our angle, and this over here is our x, which trigonometry function is going to get us the x? And that's cosine, because cosine is adjacent. And this line here is the one that is adjacent to the angle. So that would be 50 cosine of 40 times what? What do we multiply that by to get the work? So remember that this part here is what we would call the parallel force, the force parallel to distance. And the full equation for work is the force parallel to distance times the distance. So overall, the full equation would be 50 cosine 40 times 4, because 4 is the distance. Are there any questions about this? And of course, if you work that out, you would get around 153 joules. Okay. So the last piece is actually let's start to do some of this. If we have a person and this man's is holding a box or something, right? Obviously, there's a weight force from gravity, and then there's the force he applies to, keep it in his hand. What would the work done on that box be?
Are the forces equal and opposite?
You don't need to know that. All you
Alright,
need to know is the concept that he is holding it, and he is not going anywhere with it.
Oh, well then, 0, because its distance is 0.
Correct. Yep, so if he's holding it and he's keeping it in place and it's not going anywhere, then distance is 0. So force parallel to distance, there may be some force, but because distance is 0, it's not going anywhere, then there's no work done. Okay. Are there any questions so far about work and anything we've talked about? Alan, do you have anything to say?
I don't know.
I'm just trying to break the silence because it's very silent and I feel like I'm talking to myself. Anyway.
Yeah.
So that's fine. So one other thing is about energy entering and leaving a system, right? So and this is very popular for FRQs. If we go back to the I'm just going to talk through it. If we go back to the example of a lawnmower, right? If someone is pushing a lawnmower and it starts moving, right? Now that system has energy because it's moving. If that person were to let go of the lawnmower and it would slow down because of friction, then energy is now leaving the lawnmower system, right? Because friction is slowing it down. There's a force perpendicular in the opposite direction of motion, and that would be a negative work done on the system. Right? And that's actually one other thing I want to mention real quick. If the distance is this way, right, and the force done is this way, so this is D, this is F, then we would consider the force parallel to be negative, to be some negative number, right? So if it's going one way and the force is going the opposite direction of motion, then the component that is parallel is negative, and therefore the work done on the object is negative. So, like I said, if we are pushing a lawnmower, then we increase the energy. And if friction of the ground slows it down, then there's a negative work done, and that decreases the energy. However, for example, if I lift something up some stairs, right? Obviously, I'm putting energy into the system because there's some force that I'm using to lift up the stairs. But if it just stays at the top, it's not losing any energy. It has energy stored essentially in the system as potential energy. It's gravitational potential energy specifically that we'll get to a bit later. But the important aspect there is that, in a system, for example, where friction is constantly working, if there's no work being done on the system, then negative work will be done and the system will lose all of its energy. Whereas in something like lifting something up, then its energy is stored as potential energy and it stays in the system. Any questions? Okay. So it's question time. Alan, do you want to post the link in general somewhere? It's the link we always use.
Oh, it's the same link that we use? Alright, let me grab it real quick. I'll grab it with my... This is the practice questions number 1. Are we gonna continue discussing after this, or are we done with like the lecture in quotations bit?
Probably done. I mean, more than likely this is gonna take till the end. So
Right. I was
probably
gonna
we're done.
pause the recording just to or stop the recording while we were doing that, but I don't know.
Okay. I mean, I would probably keep the questions in the recording, to be honest.
Yeah, that's a very fair point. Because what I'm recording on is of course Discord, so I'm switching over to my phone to go from there. The link, is it in session planning? It should be, right?
It's pinned.
Where is it pinned?
In session planning.
Oh, in session planning. Where do you get to pin? There it is. Okay. Okay, copy link. Put that in general. It'll do. Oh,
Alright.
we'll pin that message in general.
Alright, so starting fairly easy.
How many do we have? 3?
A couple. I don't remember. Let me see what this says. I think it's 5. One of them's kind of difficult though.
Wait, sorry. I still need to log in.
Alright, it is fine. We don't start, we don't stop answers until we have more than half the people put something in anyways.
Okay, I'm in.
I
How does
realize
Wiki accept the cookie policy? I'm not so sure about this.
Whoa, cookies?
I don't. Okay, fine. Oh my god.
Lashid has been gifting me cookies in Dank Memebot, and now I have like 57,000.
Dude, that is so hot.
It's a lot of
I have
cookies.
0 cookies.
I also have like, it's insane, bro. I don't know why he did that.
Answer the question.
That's cool and all, but can you tell me how much work a supermarket checkout attendant does on a can of soup as he puts it 0.6 meters horizontally with a force of 5 newtons?
Yeah, sure I can. It's
3.
hold up, let me just.
I don't
yeah,
think it's 3.
It's not. I'm pretty sure it is.
Wait.
Yeah,
It's 3,
literally
right?
Alan, you
Yes,
literally
it is.
have the answers in the document.
Alan,
Oh my
bro,
goodness.
bro.
Shush. I was
I
assuming.
literally.
I
All right.
live with my sister. I was assuming it was a
0.6
sarcastic answer
times
coming out of
5.
her. All right. I said it without thinking.
No,
0.6
dumbass. The answer is
times
3.
All right. So my question is, why do we only have 2 people responded?
I'm coming. Don't worry about it.
All right. Cool. All right. All the better have said 3.
Okay, wait.
How much
One.
work does a
3.
supermarket?
3.
Wait, they're all 3?
Better be.
Yeah,
3
I already
J.
entered my response.
That response
bro.
is technically more correct because it specifies the unit.
All right. Moving on.
the
On my
fuck?
screen, there's no image, but on yours there should be. So that's the image you have to work with.
What
She
the
looks like she's
fuck?
held hostage, bro.
Yeah, she looks like she's from straight out of WikiHow.
I
She
mean,
good?
it doesn't matter if she's held hostage or not. That's what's being pulled 30 meters in a wagon.
I can vibe with that reasoning.
You right, Ellie?
No, I forgot what the formula for work was.
How did you figure out what the formula for work was?
It just completely slipped my
Ellie,
mind.
it's been less than a minute since we did the last question.
Were you paying attention, Ellie?
I just completely forgot. You just multiplied it by itself, right? Oh my God. Wait, I got this. Okay.
Ellie, you good?
No, I'm not good. This is pain. Wait, okay. I got this, guys. I'm gonna multiply 50 by 30. Okay?
Are you sure about that?
No.
There's something you're missing here.
Should I? Okay, I have to work. I have to work with the degree, right? The degree does something.
It is there for a reason. Do you remember what's specific about the Newton meters? The Newtons times meters for work. It's not how you the force has to be a certain force. Maybe a certain angle. Maybe
So-
maybe.
So is it like? So is it like the sine of 30 times?
Well, let's think about it for a second. So if it's sine of 30, that
Yeah.
the sine is SOH. Sine
Huh.
is opposite over hypotenuse, and
Yeah.
you have the
Oh, no.
hypotenuse
Wait. So it'd be cosine.
be cosine.
Cosine of 30 times 50 times 30.
As long as I'm using my brain correctly, pretty sure that's what it is.
That is so gamer, guys. I'm doing something.
Hold on,
Yeah.
don't lock it out yet. I'm almost done.
Yeah, don't want. I'm
I-
typing now. I gotta.
We only have
Stop.
3 people. I'm really not gonna lock it until all of you answer.
I've got
There's
it,
only
guys.
3 of you.
Oh, that's not. That's a comma, not a period.
No,
It
don't
should
worry.
be
You're
right,
just cosplaying as a Spaniard or someone who doesn't live in the U.S. It's fine.
I'm creating
Alright.
my own presentation. What the hell?
If we can get that last answer in, please.
Wait, alright, fine.
What are you typing
I was-
out that's taking so long?
I
I'm
was
scared.
trying to find a full precision calculator so I could do it up to like 1,000,000 decimal places, but apparently I can't because
I'm gonna enter another
those time
response.
functions.
No, you're not.
Oh. I only got so far. I was gonna hit submit.
Alright, so the correct answer is 1300 or close enough. So one person got it right. High quality.
Alan is gay.
What?
Alright, so since we only actually have one correct answer there, I'm going to quickly go over it.
I got this
I'm
shit
gonna
right,
ask
guys.
whoever.
Don't look at the J. Don't look at the J.
Did anyone make sure that they did their operations in degree mode?
Yeah,
Yes.
that's part 1. Make sure everyone's in degrees. But, whoops, that's a line.
A line.
Alright, so the question said we had this vector here, and it was 50 newtons, and it made an angle of 30 degrees, and the distance it traveled was 30. So in order to do this, and it travels this way, right? So we need to get the x component of the vector. So if we go ahead and we draw our high quality triangle, this is the vector, this is the angle, right? And this is the x component. Excuse my terrible triangle. This is supposed to be a right angle. So the x component there is going to be cosine because cosine is adjacent. So the full equation, remember, it's the force parallel to distance times distance. So we would be 50 times cosine of 30 in degrees mode, remember, times 30. And if you do that, you get 50 times cosine
Dude,
of
that's
30
what I did.
times 30, and you get, 1,299 rounds up to 1,300. Are there any questions about how we get this problem?
Yeah, I
I'm
have a
so
question.
smart.
What was the
Tell him
first
the J.
thought, Ellie?
I did 50 cosine 30.
Is your calculator in degree mode?
I don't know. I just used the thing that pops up when
Yeah,
you
did you
type
50 cosine 30 times 30?
Yeah. Hold up.
Double check. I can guarantee you it's probably you're not in
It was
degree.
in degrees. It was in radians. It was in radians, bro.
Oh, okay, there you go.
You have just failed the AP exam. Congratulations.
Shut up, Ellie. You didn't know that.
Now look
All
at
right,
the
next
J.
question.
That's
So,
multiple choice.
so yes, it is multiple choice. Second of all, you need to.
I have to register for credit.
What?
What is this? I can't do this question. It wants me to register for credit.
What are you talking about?
I can't answer this problem. It says register for credit. To receive credit for responses, you must register with the
Why are you on
presenter.
like the admin side or something?
Wait, I see that too.
What?
Oh no, I had
Just
that too. It
press-
just said skip.
no,
Skip for now. I just said
Just
skip for now.
press skip for now.
Does it skip the whole question? Did they add some crappy pay thing to this? That's kind of sus.
Sus. I'm gonna pay
It is
$3.
It never used to do that. Not even
It's
gonna lie.
sus.
The imposter.
Okay, so
Alright,
if I'm
stop
correct, it doesn't let you answer the question. Is that correct or no?
Just
my
hit
God.
skip, Ellie.
What the,
Does it?
what the
If
frick
you
is
hit
an
skip,
MJ?
if you
Oh,
hit
yes,
skip,
no,
does
no,
it let
yeah,
you answer the question or no?
Yeah, I'm answering the question, guys.
Okay.
I'm going
okay.
with number
That's
C,
all I
guys.
needed to
Sounds
know.
right.
As long as it lets you answer the question, that's fine. So with this, you have to think about it, right? We've talked about area under the graphs before, right? In the past, well, I don't know if Ellie was here, but at the very beginning, right, when we have like velocity and time, for example, the slope of velocity time graph is acceleration, or an acceleration time graph, the area under the graph is velocity, right? So remember that slope is always the y-axis divided by the x-axis, and area under the graph is the y-axis times the x-axis. So using the general knowledge of area under the graph, you should be able to do this.
Hey,
Also,
Is the
one
last
little question though. Like it says the elevation is 60 meters, but then like the question has it to like 10 meters. Like
no, it goes to 60.
oh wait, it's not letting lower it back down to the ground. It's just like the. Oh, so
What?
it's just been steadily lifting up. Oh, well, it took me up. I'm sorry.
You're good. You're good.
Alright, guys, I got this. So you just multiply two numbers together.
Wait, is the last multiple choice answer like a trick question, or is that a typo?
No, it's saying 18 megajoules.
Megajoule.
Do you guys know what the metric
That
prefixes
sounds
mean?
cool.
So kj is kilojoules, kn is kilonewtons, newtons is newtons, and if there was one that said mn, that would be meganewtons.
Mega.
Kilo is thousand, mega is million,
Giga
That
Newton.
sounds cool.
giga is a billion, and then tera is trillion.
All right.
And,
Also,
you know, you don't need
realizing slight typo in that graph there. The y-axis should be kilonewtons because the text below it says 10 kilonewtons, but then the graph just says 10 newtons. So it's kilonewtons. It's all kilonewtons on the graph.
Oops. Well, I did not pay attention to that, and now my answer's wrong. I'm just kidding. I have no idea what the fuck I did.
All right. Well, there are 3 responses, so we're gonna see what happened here.
No, I can't answer again.
All right.
Okay.
Fuck yeah!
Hey, I was to 600.
I told
That's
you I
like
was
the most
going.
brain dead answer.
Okay, don't believe me.
All right. All right. So first of all, let me just slap this graph into the drawing program. Is it this one?
Excuse me.
Yes, it is. All right. We're gonna zoom in and move and change the screen I'm sharing. All right. So, before I go into specifically like the math involved, does anyone know like conceptually what you have to do to solve this question?
You gotta be the crane.
All right, you know what? You're not wrong. But on the graph, what would give us work? Would it be newtons over meters or newtons times meters?
Wouldn't it be times?
Yes. And so if we're dealing with the y-axis times the x-axis, what is that on a graph? What would we call that?
Well, 10 times 60 is 600.
No,
So why
not
is it
numbers.
500?
So what would what would we call the y-axis times the x-axis on a graph?
Bullshit.
XY.
Okay.
Okay. So we would call it the starts with an A.
Axis.
Answer.
Starts with the word area.
Area
Oh,
answer.
area of the graph.
Area under the
Area
graph.
Area of a
Area
circle.
under the graph. Oh wait, you were saying something about the area under the graph.
Yeah, I wonder why I was saying that.
Oh, right, because they have
It's all,
slopes.
these
You
things couldn't
just
possibly be
multiply
related.
them. Bro. Oh,
All right. So basically, it's this area here, the area under the graph,
Yes.
that is the work done. And so the way you have to solve this is you have to realize you can split this up like this. You have a triangle, you have two triangles, and a rectangle. All right?
Trapezoid.
Or you could solve it as a trapezoid, but I'm way too lazy for that, so we're not doing it.
And
that
I
way.
don't remember what the formula is for trapezoids. I'm gonna be honest with you.
It's half of base 1 and base 2.
Look, Ellie,
and then you gotta do
I don't
the-
care. Ellie, I don't care. So, so let's start with the rectangle. The rectangle is, how long is this rectangle?
Long.
Can we
How
get a
long is this
number?
rectangle?
Okay, well 10 to 5. I mean 10 to 50. That's like
This is basic
4.
math. Please don't mess this up.
No, it's 5. No, it's 4. It's I was right the first
It's
time.
4D.
Oh,
All right,
yeah.
4D times, what's the height of the rectangle?
10.
Good. Okay, what's the area of the rectangle then?
400.
Okay, 400.
Look at you, Ellie. You can find the area of a rectangle.
Okay.
Woo!
So, next, how can we find the area of this triangle?
Half of base times height.
All right, what's the base?
The base is 10.
What's the height?
The height is 10.
All right, what's the area?
100.
You
Wait, no,
stupid!
Wait, no, actually, though, you could just do base times height and then just not add the other triangle.
Yes,
Yeah,
you
that's
could.
what I was
Yep.
doing in my mind. 250. Times
Yeah.
plus 50 is 100.
You totally did just
Correct.
forget to do the half.
Did
Shut
you
up,
just say
Alan.
250 plus 250 is 100?
Shut up. This I'm thinking.
All right, so, and that's how we get 500. It is actually very important to understand graphs and to be able to look at them and interpret them. The key main things is obviously the value of the graph, which is just the y-axis. That's easy, right? The two hard ones are the slope, which is always going to be your y-axis over your x-axis, and the area under the graph, which is going to be your y-axis times your x-axis. These will be on FRQs almost like 100%. Like it's going to be on one of them.
Okay,
With,
give me
like,
another one.
very-
I'll do that one.
I'll give it another one next time. I don't have one. I can't just make a graph on the fly.
Make a graph on the fly, Nathan.
I mean, you can make a very simple graph just by using the background and just make it be like 1 by 1 and say
Yeah, but
what's
then
the
it's
area
just.
of it.
Well, I'll put one in next time. Don't worry. Let's.
And that one I'm not gonna get 300 for. Okay.
I'd hope
All
not.
right. So this one, I'm going to warn you, is a little difficult. Not in the math, but just in thinking about it. So, if you're not understanding it, pick a random answer. We'll definitely talk about it. But really think about what's happening here.
Just to clarify, elevators work how? Is
So-
there something pulling up on it, like a string on a box?
So the thing is here is that it's a full the 15 I think we can assume here that the 1500 kilogram is like the system. Does that make sense? Is that right? Is that a fair thing to assume, Nathan?
Yeah.
So like there won't be typically if you're gonna look at this like from how elevators actually work, you have a counterweight, and and that's basically just to make it so that in order to move the elevator, the counterweight balances that out, and you only have to apply a small force. You don't have to
So,
overcome the force of gravity.
in this question, you don't have to think about the counterweight, because all the counterweight does is apply a constant force to the opposite end of the elevator, right? Which you're just assuming a constant force is being applied by the cable. That's all you need to consider in this. So, as far as how elevators work, there's some force that's applied to the elevator that accelerates it, and then there's some force that is applied to maintain its constant speed. Those are the only two parts you need to understand about how an elevator works. You don't need to think about a counterweight or any of that. Just there's some force applied that starts it moving, and some force there's accelerating rather, and some force that keeps it in motion.
Alright, guys, work is like one number times another number. 100 times 40. It's 4,000. Yeah.
Ellie, are you okay?
No.
I can tell.
Wait, did you like lose sleep again or something? You sound like I don't know, like sleep drunk. You know what sleep drunk is? Like you just like it's 3 in the morning and you act like a crackhead. It's my goal to always act like that, but I feel
Yeah,
like you're just doing.
You need to
think
get some
about it,
better
you know,
goals in life, Tehan.
You see,
Hey,
I
also wanna be, like,
I got Wendy's.
something.
They're from DoorDash, and the bag was open, and I think they put crack in it, and that's why I
When
was
did
up
you
for
get
3
Wendy's
days.
from DoorDash?
I got Wendy's and DoorDash for like dinner one night because I was sad.
Was it because of the 89 test?
Yeah, and then I got a PDQ after I got my 83 on my test. I was depressing. It was the first time in a long time I got a B. It was pain.
Dang, imagine.
I was like, I gotta cry now. Oh my god. Was I right? Do I have to multiply that? But then you also got this whole other number. Do I gotta multiply all 3 of those together?
Well, I mean, we won't be here to help you on the test.
Okay, I got this. Tehan, you gotta multiply
Tehan will be there to
that
help you on the
together.
AP test. Maybe they'll help you
I
in your
what?
class tests.
What'd I do?
Tehan,
She's
Tehan,
trying to
you
get you to.
multiply all
He's
3
trying to
numbers
have you
together.
commit epic academic dishonesty. Don't listen to her.
Hold up.
Stay
Bro,
hot.
if I do that, I gotta report myself to the IB, man.
Yeah, you don't want to report yourself to
No.
IB.
Do that.
I got a big number.
Wait, I haven't gotten a number yet.
I just multiplied them.
Are you just calculating A right now?
Yeah.
Okay. How many different numbers are you adding together to find the one number?
Well, see, I thought it was just 40 times 100, but then you got another number in there. What do I do with that?
Nah, it ain't. It's not 40 times 100.
Oh.
As far as I can tell, it's not 40 times 100. Like, because the thing is, isn't like weight force going in like the other direction, so like doesn't have to counteract
I'm
that.
gonna fail.
Bingo! Ooh.
Yep.
I'm so gonna fail.
Well,
Hey
no,
guys,
because
I'm just gonna
okay,
put-
you would fail if
That's
you
fine.
if you weren't here for the tutoring sessions, because then you wouldn't know these things.
I said the answer.
Tehan, what did you get?
Did you answer A, B,
Alright,
and C?
so I feel like we should at least we should start by going over A, because we only have one response. It's been like 5 minutes.
I'm trying my best. I just don't know what numbers to multiply. They
Alright,
thought
so
work
here.
Sometimes
was
it's more
millions
complex than
times
just multiplying
big.
numbers, Ellie.
Alright, so
No, multiply number.
alright, I'm gonna keep it open so you can answer at any time, but I'm going to go to the thingy. Alright. So there's a couple of things to know here. So we have elevator, right? We also the problem said, which is the key part of the question, it said to lift it at a constant speed. So if it's lifting at a constant speed, what does that mean? What would its acceleration be if it's lifting at a constant speed?
It would be the 0.
Right. And if its acceleration is 0, what is the net force?
It is 0.
Correct. So if we have a cable, and this is some force that we don't know, right? And then what other forces are acting on the box, or in the elevator, specifically in the downward direction?
Weight and
The weight
friction.
force. The weight force, and then
Yeah.
there's also, yeah, the friction force. And
So
this is
cool.
1,500 kilograms. So first of all, it tells us that the force of friction, which I'm going to write as F of F, is, what is it, 100? 100. Yeah, 100. How do we find the weight force?
Mass times gravity.
Yes, mass times gravity. So that's just going to be 15,000, which you could just use 10 in AP. Alan, the answers on our answer key, by the way, use 9.8, so kind of just ignore them. But anyway, so that is the weight force. So what is the total force in the downward direction on the elevator?
It would be 15,100.
Yes. One.
That is so cool, Tehan. I'm so proud of you.
Thank you.
Because you
So-
have to add whatever number you just multiplied plus the friction.
Amazing, right? So remember we
Oh
said
my god,
earlier.
that's insane.
Remember we said earlier that acceleration is 0. So what if the acceleration is 0 and the net force is 0? What does this force have to be? The force of the cable.
It has to be 15,100, but in the other direction.
Correct.
Negative.
So actually, I'm going to make this one negative just because it makes more sense. But
Okay.
we'll say down is negative, and then the other one is 15,100. All right, let's make that not look like a 6. All right,
It
it's
doesn't
not
look
better.
any better, Nate. That looks like B.
All right, close enough. So the first question asks, what is the work done on the lift by the cable? So if we know the cable force is that, and we know it's going up, what is the force parallel to distance?
604,000.
Okay, now I multiply shit. I got it, guys.
How did you get
Yeah,
600?
I got.
I did it times 40.
Yeah. Oh my god, that's what
Okay.
I just did, Tehan.
Okay.
Yeah.
Okay, technically didn't answer the question I asked, but that is the final answer. The question I asked was, what is the force parallel to distance, though? I want to get that part first.
Force
wait.
parallel to distance. Wait, what do you mean parallel?
So remember, so this is the force up here. The force is going up, and the distance, or the direction it's going, is also up. So what is the component of force that is parallel to distance? Is it any different than the force itself? Another way to ask it. No, it's the same, right? If for some reason it was pulling it this way, right, then we would have to get the actual, force going upward. But because the force is already going upward, it's fine. 1,500, 15100 is fine. So we
Wait, so I
multiply.
got it right then. Excellent.
Yeah, you got it right. I'm just pointing out that you need to make sure you're using the force parallel to distance.
Alright, so I also gotta account for the angle.
Yeah,
Like,
if there is one.
got it.
In this case, it's going in the same direction, so it doesn't matter. So the force parallel to distance is 15100, and then the equation is force parallel to distance times distance. So distance is 40. So you multiply those together, and you should get 604,000, right? Something like that.
604,000.
Yes. Okay. So that's how you get part A.
Wow.
So now that you know that, let's try and
Wait,
do
this is part A?
That's part A. Now that you know that, let's try and do part B.
Yeah, that was a mean question. It's got 3 parts too.
Remember how many parts they have for a Q, Ellie?
I'm gonna hit you with a Prius, Alan.
I'd like to see you try.
You-
Bitch, I don't have my license. You know I'm gonna be able to hit you and not care.
I also know that what you should do is the problem right there. Part B.
What is the work done on the lift by the gravitational force in this process? Gravity is 9.8. So it just wants the gravitational force, so you get rid of the friction.
Nah,
Is that what
so
it's asking?
for B, I said it was Wait, should I say my answer for B?
Sure, go ahead.
Yes.
I said it was 0.
It's not
Because
0.
It's not
Wow.
0.
What?
Damn it. But the gravitational force isn't doing anything to it. So it's not like,
Oh yeah, yes it is.
Yeah, it is.
There is always a gravitational force, Tehan.
damn it.
Always.
Yeah, but it's like, it's, oh wait, even though it's not like actually the force that's like finally determines which direction it goes, it's still acting on it, so it's still.
Exactly.
Oh, shit. Ah,
So wait. So then is what I said right? Like you just do it without the friction? Is that what it's asking? What is the work
yeah,
done
yeah.
by
So,
just the
like,
gravity?
so doing it that way, so doing it the first way you said would get you the right answer. The second way, the way you just said, is the better way to think about it. But they would both get you the right answer. Just the first way, thinking about it, taking out friction, is not the right way to think about it. But technically, they would both be the same, the correct answer.
Is
Like-
it
So
3,920?
Say it again.
Is it 3,920?
No.
No.
It would just be 15,000 times 40 then, right?
But what about
Yep.
gravity? Oh wait,
Yeah.
what?
Because it's just gravity to wait
Nice
force.
job.
Oh my god!
Yo, I did something. Holy shit.
I'm proud of you, Ellie. So, just to go over how that one worked. Okay, let's go back to our high quality diagram. If I can find the screen, it is. There it is. All right. So let's look at this. Right. Which force? That's a line.
That is a line.
Which force on here is the gravity force? Don't mind me casually erasing a
The
zero.
big one. 15,000.
Yes. So, and remember right here I added a negative because we'd say it's going down, and more specifically, not just it's going down, but it's going in the opposite direction of motion, right? So since the weight force is pulling it down, but the elevator is moving up, we would say it's negative, right? And then obviously to find the work done by this force, we just multiply negative 1,500 times the distance it went, which is 40, and that should get us negative 600,000, right?
Oh, I forgot the negative.
Yeah, so you did forget the negative, but you know it was good enough. Um,
Yeah.
So, and what unit is this? Anyone?
Joules.
Joules, good job.
Yeah.
So remember that whenever there is motion, right, there can be a number of forces acting. There may be friction, there might be a pushing force, there might be gravity, whatever, right? Every single force can have a work done on an object, right? But for some of them could be 0. Like if I have a box and I push it this way, right? There's a normal force from the table, and there's a weight force from gravity, and then there's the force pushing it to the right. Obviously, the normal force from the table and the force of gravity do 0 work on the system, right? This force here would be the only force that does work on the system. Whereas in the elevator example, all the forces involved, have some component that is in the direction of motion or against the direction of motion. So they all do some work on the system. But if you were to calculate them out individually, so negative 1,500 the friction and then the one from the upper force, right? You would get the answer to C. And so let's go ahead and do number C. I will tell you right now, although I said that you can add it up, there is a far easier way to get the answer to part C.
Yes. There is a way to basically say, I know that there is no work done because of something that's written in the problem.
A way to give away the answer, Alan.
Oh,
That's still not giving away the answer.
Number C-
100 times
Wait, number
2.
C, the total work done is 0 because they cancel each other, right?
Yes.
Well,
And the key to that is that it says at a constant speed, which means acceleration is 0, which means net force is 0, and if there is no net force on the system, the total work on the system is 0.
Oh my god, I'm so smart.
Good job. So does anyone? We're gonna just because I'm curious. Let's see what happens if I.
Oh no.
why are there 7 results?
I think
Oh,
they
because
answered part A.
I put
That
it
was me, bro.
on my own.
Multiply numbers.
Don't
Ellie.
worry about it. See that? Okay, that's my first one. Okay. Mine. That's mine.
Okay, but in all seriousness, does anyone have any questions? Because this, for example, is could be obviously this is simplified, but this could be an FRQ style question. So does anyone have any questions about how we did this, or just in general?
Why are there 7 responses?
That's not a
If
question
no one
about
says anything,
energy.
I mean,
no, there's
so
another
like,
one. What the fuck?
so there is another one, but it is like 7:35. So if you want to leave, you can. If you want to do the last one, you can do the last one.
Bye, host. I gotta do
Alright,
chemistry
I'm
work.
probably gonna head out as well.
Alright, thank you though. I appreciate it.
apologize.
Don't do drugs.
Noted. All right. Rip, last question about potato cannon.
Yeah.
I thought the last question was good though. I mean, it was difficult, and I knew that, but it was a useful question.